In this video, I'm going to work through exam 1 from 2022. Sorry, that should be 2022. So problem 1. This is a arbitrage problem. You are presented with a scenario where you have a large supply of baby formula now, but you expect that there'll be a shortage of baby formula in the future. So we have the same demand for baby formula, basically, in today and 6 months from now, but the supply today is much farther over to the right. So that gives you Q1. And then in the future, it's going to be much closer to the left. So that gives you Q1 in the future. So the question is, what can you do, or what would you advise the governor to do if you knew this was going to create a public health crisis where there's not going to be enough baby formula? Well, the answer that I'm looking for is to arbitrage between today and tomorrow. And the way you do that is you would reduce your supply today, or you would have the governor buy a bunch of baby formula on the market today, which would reduce the supply, and then take that baby formula from today and bring it over to 6 months from now, or hold it over till 6 months from now. So what you could do to make this, the best way to do this would be to draw a single line. So we would have, sorry, I should get ahead here. So we would have P1 here and P1 here, right? So P1 today and P1 6 months from now. We draw a single line that's going to have the same price in both today and 6 months from now. We'll call that P2. And so we would have a new supply curve, S2 here and S2 here. Right, that's supposed to go right through that intersection. So we would see Q1 go down to Q2 because I'm taking supply. I'm taking this much supply and I'm putting it into storage. So the governor is using the state funds to buy this much Q1 minus Q2 amount of baby formula. And then we're going to take it into the future, right, and add it here and then release it into the market 6 months from now, increasing the quantity, which will bring the price down to P2. So by buying up a bunch of formula today, we reduce the supply that raises the price today. And then we release it in the future when there's a shortfall, and that brings the price down from P1 to P2. And you may have heard of the Strategic Petroleum Reserve that President Biden has been releasing, and he's basically doing this. The United States government has a large reserve of oil, and when the market gets crazy and there's not enough oil, it can release the oil into the market. So this is exactly what's happening right now in the United States. All right, the next question talks about epinephrine auto-injector pens, or EpiPens, that are used for people with allergic reactions. And so right now they're selling for $500 in Florida, but they're $150 each in New Hampshire. What would you expect an entrepreneur to do? Well, what an entrepreneur would do is buy in New Hampshire at 150 and bring those to Florida and sell them there. And what we would expect to have happen is the price in New Hampshire would rise as the entrepreneurs bought the EpiPens in New Hampshire and sent them to Florida, and we would expect the price in Florida to go down. So how long would this go on? What would the expected end state be? We would expect the price in New Hampshire, P New Hampshire, to equal the price in Florida, right? And at that point, the prices would, the entrepreneurs would no longer be able to make a profit. So I was looking for a verbiage like that. And if you wanted to, you could actually calculate the amount. So right now, the price in Florida is 500. The price in New Hampshire is 150. And what we would expect is to have something halfway in between. So 500 minus 150 divided by 2 is 350 divided by 2, which is 175. So what we would expect to have happen is for P Florida to go down by 175, which would be 325. and P New Hampshire to go up by 175 to 325. And if you wanted, you could have drawn the same kind of graph that we had on the prior page, where we had, say, Florida and New Hampshire, right? And Florida is currently at 500, and New Hampshire was at 150. Sorry, 150, right? And so what you would expect is for the prices to equalize at 325 and 325. And so you would expect the entrepreneurs to buy Q1 minus Q2 amount in New Hampshire, ship it to Florida, where Q1 would increase to Q2, right, with S2, and the price would fall to 325. I didn't require this. I didn't even require you doing the actual dollar amount. All I was really looking for was for you to say that entrepreneurs would buy in New Hampshire, sell in Florida until the price in New Hampshire equalized to the price in Florida. All right. This next problem talks about daycare in Dover, and someone decides that that $300 a month or a week is too expensive, and that a fair price would be $200 a week. And so they set a price ceiling, right? Price can't go above. So price ceiling of 200. What's the result of that? Well, we just follow the price lines through to their respective, through the respective supply and demand functions, and the price hits the supply curve first, so that's QS, and then QD. The gap is going to be a shortage. Why? Because at a price of 200, we'll get less supply of daycare, and at a price of 200, there'll be more people that want the daycare, and so we'll have we'll be out of equilibrium. How much daycare do they want? Well, the way we figure that out is well, first Q supply, we take the $200 price and we plug it into the supply function. So 200 equals 50 plus 0.5 Q. 200 minus 50 is 150 equals 0.5 Q. Multiply this by 2 to get rid of the half, and you get Q supply is equal to 300. So that's 300 QS, and then QD, push up here, QD, we take $200 and plug it into the demand function, which is 200 equals 700 minus 0.8 Q, sorry, Q. So 700 minus 200 is 500, add 0.8 to both sides, we get 0.8. Q is equal to 500, divide through by 0.8 on both sides. That cancels, and we get 500 over 0.8, which is 625. So QD equals 625. So the shortage equals 625 minus 300, or 325. Next, for those children who are able to get daycare, what is the full economic price per week? Calculate the price and show it on the graph. All right, so we know some kids get it. 300 kids get to have to pay a cash price, or their families get to pay a cash price of 200, but the real price is found by drawing the quantity of 300 up to the demand curve. That gives us P full, And this will result in a long waiting line, right? We talked about that when something sells for below market price, you inevitably wind up with a line. And so we're going to take the quantity of 300 and put it into the demand curve. So T equals 700 minus 0.8 times 300. 0.8 times 300 is 240 plus 700, make it negative, so plus 700 is 460. So P full is 460. So there'll be effectively a $200 cash price and $260 in waiting time. So you'll have a long line where you'll have to wait a long time, and that will waste a lot of resources. What is the deadweight loss as a result of the new pricing policy? Okay, the deadweight loss is the lost trades. So we would have made 500, but we actually make 300. So the deadweight loss is this triangle here. So it is 500 minus 300 wide. It is from the 500 over to the 300, and then it is 460 minus 200 tall. Times 1/2. So 460 minus 200 is 260. Times 500 minus 300 is 200. So 200 times 260 times 0.5 gives me 26,000. So a lot of waste. All right. Next problem is also from, I think this is chapter 8. I forget. Yeah, whatever. So here now we've got a supply of LNAs at a hospital. Their equilibrium price is $18 an hour. The number of LNAs hired is 200. Now there's a union contract that requires the hospital pay $22 an hour. So now we have a price floor, which means you can't go below 22. Right, so we're going to draw lines down from the demand and supply curves now. And so now the QD and the QS, right, switch places. We're going to have a surplus because at $22 an hour, the hospital demands fewer employees, but at $20 an hour, there's a lot more people want to work there. So we have a surplus of workers. How much is the surplus? Well, the demand, we'll start with demand at a price of 22. Is equal to 34 minus 0.8 Q. I shouldn't have used 0.8 twice. That is what it is. And you don't think about these things while you're doing it, while you're writing them. So 34 minus 22 is 12 plus 0.8 Q to both sides, then divide through by 0.8. And we get Q is equal to 12 divided by 0.8, 15. What did I do wrong here? Hold on. 0.08, that's what I did wrong. 0.08, copying error. 0.08, that should have been 0.08. So dividing through by 0.08. I knew that was too small a number. So 12 divided by 0.08 is 150. So the quantity demanded falls from 200 to 150. And then the quantity supplied is going to be based on P equals 10 plus 0.04 Q. So where P is 22, so 10 plus 0.04 Q. So subtract 10 from both sides, we get 12 equals 0.04 Q, right? And so divide through by 0.04, get 12 divided by 0.04, and we get 300. So the surplus is equal to 300 minus 150, or 150. Okay. The next question is more of a theoretical question. I don't ask you to calculate quality waste, but basically, so we ask you to use the idea of compensating differential to talk about how the managers will treat employees after this new union rate is put in place. Well, if we know that, so a couple of things. One is the managers know that this 22 is an artificially high number and that they could really have 200 people, but they're being forced to only have 150. So they're going to be less tolerant of people messing around, taking a long smoke break, right? If you pull your phone out while you're at work, you're probably going to get yelled at, right? So they're just not going to be nice. And they're not going to be nice to the tune of this much, right? We didn't ask you to actually calculate that, but they'll not be nice. And basically the managers will just be meaner. They'll try to force the workers to work harder. And the reason they can get away with that is because they know that there's 150 people waiting outside the door to take your place. So if you're one of the employees, you're like, hey, I get to get a $23 an hour instead of 18, yay. But now the managers suddenly get really mean, and it becomes a less nice place to work. And so that's the idea of compensating differential, is the cash you receive for working at a job is only part of your compensation. The other part of your compensation is the quality of the experience of working there. And that quality of experience can be made nicer if you're paid below market rate. Your managers will be really nice to you. And if you are paid above market rate, your managers will be mean to you, not just to be mean, but to try to extract more productivity out of you. So that's basically what I was looking for, is something along those lines. No math involved there. All right, there was a typo here. I told you to use 450. Yeah, not 430, because that, of course, lines up here. So the question is about an externality. Basically, the Chinese are able to sell the solar panels to the United States for 200, but that's not including the environmental damage that they're doing. So as we all know, the Chinese use coal-fired power plants. They don't respect the environment the way that we require in developed countries like the United States and Europe. And so they're imposing a social cost of $30. Where is it? $30 per unit. So the social cost curve you'll draw as a line going up, parallel to the supply curve, but at $30 higher. The optimal Q social would be to produce where the social cost curve crosses the demand curve. And then this triangle will represent deadweight loss. Why is that deadweight loss? Well, we're still getting the 10, right? And consumers are getting this portion of the social cost contributed to their well-being, and the suppliers are getting to keep this portion of the social cost, kind of like it is some sort of subsidy, but nobody's getting this portion out here. And this is the deadweight loss. The social cost that's created out to 10, right, is that area here. Okay, so then the question is, I think the next question is, what's QS? Yeah, so calculate the socially optimal quantity of solar panels. So I take 450 minus 25Q for the demand curve, and then I'm going to use the social cost curve to find QS, which is the intersection between the demand curve and the social cost curve. So the social cost curve is 130, is 100 plus 30. So it's 100 plus 30, right? That's the social cost per unit plus 10Q. So now I'm going to solve for Q. So I'm going to add 25Q to both sides. That gives me 35Q. And then this is 130. I'm going to subtract 130 from both sides. That gives me 450 minus 130, 320. Divide through by 35. And I get Q, 320 divided by 35. I get Q is equal to 9.14, roughly. And then, so we labeled the deadweight loss already. It's that. So calculate the deadweight loss. Okay, so the deadweight loss, we know that QS is 9.14. Right? So the deadweight loss is 10 minus 9.14 wide, right? And then how tall is it? Well, it's 30 tall, right? The gap between this pink line and this line here is 30 all the way up. So that is 30 times 1/2. So keep that there. So plus 10 times 30 divided by 2 is 12.85, 12.9. All right, then give an example of a healthcare related or public health related good or service that consumers purchase that has both private value and positive externality. The easiest one is vaccines, right? The private good is you're less likely to get sick, and the public good or social good, which is the positive externality, is you are less likely to make someone else sick. Right? That's all I was looking for there. All right. We've got Gordon Medical Supply. The market for crutches is $35 each. What is GMS's marginal revenue? So we start with their total revenue is price times quantity. So price is 35Q. So the marginal revenue is the derivative of 35Q. So that's really Q to the 1. So I bring the 1 down. Then I bring the constant down, 35 times or Q to the 1 minus 1, right? Which is 1 times 35 is 35 times Q to the 0. Well, Q to the 0, anything to the 0 is 1. So 35 times 1 is 35. So the marginal revenue is 35. What is GMS's marginal cost? Well, that's the derivative of the total cost curve. So 25,000 plus 5Q plus 1 over 200 Q squared. So marginal cost, what do I do with a constant that doesn't have a variable? Right, that's just 0. 5Q, that's Q to the 1, right? 1 times 5 is 5 times Q to the 1 minus 1 is Q to the 0. So 1 times 5 times 1 is 5. For this term, I bring the 2 down. So 2 times 1 over 200 Q to the 2 minus 1. So I've got 5 plus 2 times 1 over 200 is 2 over 200, or 1 over 100. And then Q to the 2 minus 1 is just Q to the 1, which is just Q. So the marginal cost is 5 plus 1 over 100Q. What is GMS's profit maximizing quantity? I take marginal revenue equal to marginal cost. So my marginal revenue is 35, and my marginal cost is 5 plus 1 over 100Q. Subtract 5 from both sides, I get 30 equals 1 over 100Q. Multiply both sides by 100. That cancels that, and I get Q is equal to 3,000. All right, what is GMS's profit at a price of $35? So with a Q of 3,000, the total revenue is 35 times 3,000. 3,000 times 35 is 105,000. The total cost was 25,000 plus 5 times 3,000 plus 1/200 times 3,000 squared. So I've got 25,000 plus 5 times 3,000 is 15,000. And then we got to do a little bit of calculating here, but 3,000 times 3,000, that's 3,000 squared is 9 million. Divided by 200 is 45,000. So 45,000 plus 15,000 plus 25,000 is 85,000. So total revenue is 105, total cost is 85. So profit is total revenue minus total cost, which is 105,000 minus 85,000, 20,000. Would you expect additional competitors to enter this market? Why? Yes. Why? They are making excess profit, right? If they have a positive profit, in other words, profit is greater than zero. If they have a positive economic profit, then they are making excess profit, which attracts competitors. That's it. All right. Last two are basically just asking you to do what we just did, but just graphically. So given the graph in part, assume the below image represents the curves price, cost curves and price. Complete the graph by indicating the profit maximizing quantity, the total cost, total revenue, and profit or loss. All right, so where do they produce? Well, they produce where P equals MR, right? So when we have a constant price line or a fixed price, say P, that's MR, where do we produce? Where MR equals MC. Where does MR equal MC? Where the MR line crosses the marginal cost line, that's right here. So we draw a line down. That is Q profit maximizing, right? And then how much is their average total cost? It's wherever the quantity line crosses the average total cost curve. So we draw a horizontal line back over to the dollar axis. That becomes our average total cost. This whole area, you don't have to do this, as long as you indicate it in some sense that this whole area is total revenue. So the blue is total revenue, right? Because it's price times quantity. And then this area is my total cost, right? So the from average total cost times quantity, right, gives me my total cost, because average total cost is equal to total cost divided by quantity. And if I take total cost divided by quantity times quantity, the quantities cancel and I get total cost, right? So that's what this is. And then profit is total revenue minus average total cost. So this area is profit. All right, so that's what I was looking for. Given the graph in A, is this earning normal profits, excess profits, or making a loss? It's making excess profit because profit is greater than zero, right? We have a positive profit here. And when we have a positive profit in this model, it's excess profit. You could also say, I know they're making a excess profit because P is greater than ATC at Q pi max, right? So this, when P is greater than ATC, that means we're making a profit. All right. Given the graph in A, should this firm continuing operating shut down in the long run or shut down in the short run? Why? It should keep running. Keep running, right? Because it's making a profit. Why would they shut down? They're making a profit. They're happy. All right, next. Same sort of problem. We're looking for, again, where are they going to produce? Well, they're going to produce, again, where P equals MR, right? So where does MR equal MC? Well, it equals it right there. So I'll draw a line down. That's my Q pi max. But notice in this scenario, price is below the lowest point of average total cost. So we're going to draw a line, that line all the way up to the average total cost curve. We've got average total cost is above profit, so that means we have a loss. This area here now is P times Q is total revenue, right? And then this whole thing, in this case, this box, right, is my total cost now, because that's my ATC times Q, right? And so in this case, it is making a loss because total cost is greater than total revenue. You could also say ATC is greater than P, right? So that's how we know, right? The overall total cost box is bigger than the total revenue box, so they're losing money. Okay. Given the graph in D, should this firm continue operating, shut down in the long run or shut down in the short run? Why? Well, let's go back up here for a second. Price is below the lowest point in average total cost, but it's above the lowest point in average variable cost. So at Q pi max, at this quantity, if we look at the gap here, right, this gap is my average fixed cost. Sorry, it doesn't get any sharper than that. The gap between average total cost and average variable cost is my fixed cost. So at this point, our average fixed cost, excuse me. So at this point, right, at this quantity, we're covering all of our variable costs, right, which we draw the line from where the quantity line crosses the average variable cost line. So this gap here is the fixed cost. So it's covering, so the price is covering the variable cost, but not the fixed costs. So that means that you should continue to run in the short run, shut down in long run. So they're going to stop. They're earning a little bit of, they're covering their cost per unit. That's the average variable cost, but they're not covering their fixed costs like their rent and their salaries. So they should keep running as long as they don't have to pay another round of rent, for example, and they can cover part of their rent, but not all of it. And so, so when price is below average total cost, but above, so this condition here is when average total cost is greater than price, but price is greater than average variable cost, then you have this condition where you continue to run in the short run, but you shut down in the long run because you can't afford to cover all of your total costs, which is the difference being your fixed costs, right? So you're covering your variable costs, but not your fixed costs. So therefore you can't cover your average total costs. All right, that's the whole exam.